Hey guys, this is CHEMPLIFIED and today we will learn how to calculate oxidation number of a particular element in a molecule. Before we start this video, take a look at the previous video in which we talked about the rules and regulations that you have to follow to calculate the oxidation number. Alright, in this particular video we will choose different examples and we will try to find oxidation number of one atom in that molecule. Let's start. Our first molecule is KMnO4. Here you have to find the oxidation state or oxidation number of manganese. Before we start calculating, let's make some things clear. Whichever element you are choosing to calculate oxidation number, take the oxidation number as X and write down the other oxidation numbers from the rules that we have completed in the previous video. Let's start. Now, oxidation state of potassium is generally considered as +1. Why? Because it is group 1 element. According to the rules, potassium will have +1 oxidation state. We don't know the oxidation state of manganese, so we will take it as X. And last, oxidation state of oxygen is -2. But how many oxygen atoms are there? 4. So you have to multiply it with 4. Now according to the rules, the algebraic sum of all the oxidation state of all the atoms should be equal to 0. So this is equal to 0. Now start calculating. +1 plus X plus -8 is equal to 0. X minus 7 is equal to 0. X is equal to +7. Here X is equal to manganese. So oxidation state of manganese is +7 in KMnO4. We are talking only about KMnO4. So this will be the oxidation state and that's how you have to calculate. Let's move to the next example. We will try to do everything fast. Now you have to find the oxidation state of chromium. The molecule is K2Cr2O7. We know that oxidation state of potassium, that is group 1, is generally taken as +1. How many potassium atoms are there? 2. So you have to multiply it with 2. Plus there are 2 chromium atoms. 2 into X plus 7 oxygen atoms. So 7 into -2. Overall it is equal to 0. Solve it. You will get 2 plus 2x plus -14 is equal to 0. After solving you will get 2x plus -12. We solve this one and this one. After solving these two you will get -12 is equal to 0. 2x is equal to +12. X is equal to +12 by 2 is equal to +6. So the oxidation number of chromium is +6 in K2Cr2O7. Let's move to the next example. Our next example is Na2S2O3. Now in this example you have to find the oxidation state of sulfur. Again start writing according to the rules. Sodium has an oxidation state of +1 because it is in group 1. There are two sodium atoms, so multiplied with 2 plus 2 sulfur atom. You will get 2x plus 3 oxygen atoms is equal to 0. Solve it. 2x plus -6 equal to 0. 2x plus -4 is equal to 0. 2x is equal to +4. X is equal to +4 by 2 is equal to +. So oxidation state of sulfur is +2 in Na2S2O3. I repeat, oxidation state of sulfur is +2 in Na2S2O3. Why? Because oxidation state varies from molecule to molecule for every element. Sulfur has an oxidation state of +2 in this case, but for example, if we take H2SO3, H2SO4, and if you find out the oxidation state of sulfur, it will be different, right? So be careful about that. Now let's move to the next element is CH2Cl2. Here you have to find the oxidation state for carbon. You have to find the oxidation state for carbon. So start calculating. First take X plus, now hydrogen. Hydrogen is considered to have +1 oxidation state. The exceptions are hydrides. In case of hydrides, the hydrogen will show negative oxidation state. But this is not a hydride, so you will write X plus 2 into +1 plus, now chlorine has a negative charge, so 2 into -1 is equal to 0. Solve it. X plus 2 plus 2 into -1 is equal to 0. X plus 2 minus 2 is equal to 0. 2 minus 2 will be 0, so X is equal to 0. So here oxidation state of carbon is 0. Alright. In CH2Cl2, oxidation state of carbon will be 0. Let's move to the next. Our next molecule is CHCl3. Again start. X plus +1 for hydrogen plus 3 into -1 is equal to 0. X plus 1 minus 3 is equal to 0. X is equal to 2 plus 2. Right? Let's solve it a little bit more. X plus -2 is equal to 0. X is equal to plus 2. So in this case, oxidation state of carbon is +2. Right? As the molecule changes, the oxidation state also changes. Remember this. Now let's move to the next. Now this is a different molecule. This is an ion, all right, because there is a negative charge. ClO4 negative. You have to find the oxidation state of what? Chlorine, right? Now be careful about this one. We will take chlorine as X plus 4 oxygen atoms are there, 4 multiplied with -2 is equal to, this time we will not take 0, it will be wrong. Since the overall charge on the molecule is -1, so we will take algebraic sum is equal to -1. The algebraic sum of neutral molecules is equal to 0, and if there is a charge on the molecule, then the algebraic sum should be equal to that charge. Alright. Now X plus 4 into 2 is -8 is equal to -1. X is equal to -1 plus 8. So X is equal to +7. So oxidation state of chlorine is +7 in ClO4 negative. Next, Cr2O7 2 negative. Here you have to find the oxidation state of chromium. You will write 2x plus 7 into -2 is equal to -2. Why? Because overall charge is -2. 2x plus -14 is equal to -2. 2x is equal to -2 plus 14. 2x is equal to +12. X is equal to +12 by 6 is equal to +6. So chromium has an oxidation state of +6 in Cr2O7 2 negative, right? Next, Na3PO4. Here you have to find the oxidation state of phosphorus. Now sodium has an oxidation state of +1. How many atoms are there? 3. So multiply it with 3. Take X for phosphorus and 4 into -2 for oxygen. Overall there is no charge, so equal to 0. 3 plus X plus -8 is equal to 0. X plus -5 is equal to 0. X is equal to +5. So oxidation state of phosphorus in Na3PO4 is +5. Let's move to the next. PbSO4. We have to calculate for PbSO4. Now in this particular molecule, you have to remember a few things. We know that SO4 exists as SO4 2 negative. The whole SO4 molecule or whole SO4 part will exist with a -2 charge. So by this we know that overall charge in the molecule is 0. Overall charge is, if we write it as the molecule, the overall charge is 0. And we know that SO4 has a -2 oxidation state. So we know that Pb will have a +2 oxidation state. By this we can find the oxidation state of Pb. But we need to find the oxidation state of sulfur alone, right? So by this process we find that oxidation state of lead is +2. Now start writing. +2 for Pb plus X for sulfur, and for oxygen you can write as 4 into -2 is equal to 0. Now continue. +2 plus X -8 is equal to 0. X is equal to +6. So oxidation state of sulfur in PbSO4 is +6. Now you need to find oxidation state of sulfur in NH4 to SO4, right? Now again get some help from other molecule, NH3. This is neutral molecule. If you add one more hydrogen to NH3, you will get NH4 and the overall charge is plus. So NH4 will have +1 charge, right? And there are two NH4. Start solving. 2 into +1 plus X for sulfur plus 4 into -2 is equal to 0 because overall charge is 0, right? 2 plus X minus 8 is equal to 0. X is equal to +6. So oxidation state of sulfur in NH4 twice SO4 is +6. Now if you want to find the oxidation state of nitrogen, you can also do it by using these given oxidation state. We have already find the oxidation state for sulfur. We know the oxidation state of oxygen. We know the oxidation state of hydrogen. Using all these three, we can calculate the oxidation state of nitrogen, right? You can do it on your own. Now let's move to the next. This is very common. This is glucose, C6H12O6. You have to find the oxidation state of carbon, right? 6 into X plus 12 into +1 plus 6 into -2, right, is equal to 0. 6x plus 12 minus 12 is equal to 0, right? It gives 6x is equal to 0. So x is equal to 0 by 6 is equal to 0. So oxidation state of carbon in C6H12O6 is 0. Now this is the last one, today's last example, and also an important example because this example will lead to our next video topic. The molecule is Pb3O4. We have to find the oxidation state of Pb. Let's start. 3 into X for Pb, 3 atoms are there, plus 4 into oxidation state of oxygen is -2 is equal to 0. Right? Now start solving. You will get 3x plus -8 is equal to 0. Take -8 on the other side. X is equal to plus 8 by 3. Now this is something known as paradox. Paradox of fractional oxidation number. This is known as paradox of fractional oxidation number. Until now, we have calculated so many oxidation numbers, but none of them were fractional. This is the first one where we have found fractional oxidation number. This is known as paradox of fractional oxidation number, and we will discuss this topic in the next video clearly. This is not wrong, this is also right, but how this is right, we will discuss it in the next video. So wait for the next video. This will be it for today's video. Thank you very much.